Alright, this is episode 12. Now we're gonna do WHDS transformations. So if I open transform.hpp, yeah, we dealt with Jacobi and democratic heliocentric. Now all that's needed is to deal with WHDS. First off, how to convert WHDS coordinates. Why do you need that? I don't want to. Okay, let's see if I could go directly to the paper and view PDF. Okay, here we go. If the time step H is small enough, the error Hamiltonian and oh, come on, I just want the conversion. You know, Gemini, please summarize. Right now while I'm waiting, I'm just gonna do implement. my favorite to do, even though it makes literally. Okay, investigate this. It did not give me anything related to WHDS coordinates. Does it have anything about WHDS coordinates? Okay. You know, why are things stupid? I could probably have just, yeah, I could probably could have just, found something, just like WHDS. Okay. Here, let's search that. This coordinates, we just have math. I'm looking for the, how can I convert to and from inertial? Yeah, okay, that's what I really want right now. So X is Q. So Q0 is the center of mass. So isn't this literally just the center of position? Yeah, I don't know. Total system momentum, that's like centric, you know. Should I give Gemini this? Let's give this. See if, don't give any code. Okay, so this is a good use of AI, because if I don't want to Google everything. Okay, the core difference is just called WHDS relative to center mass structure that limit the linear momentum of the gravitational system, of the background system. Here's exactly how you need to modify your logic to implement the initial to WHDS. Your current initial to helium compute the center of mass and assign to index 0. Other has the standard heliocentric coordinates. X0 is the inertial position of the star, and planets is relative to heliocentric still. Okay. Makes life easy. So, pH dot positions index 0 should equal particle dot positions index 0. Yeah, I'm gonna make the basic assumption that the star is the central mass and not that's the major one. If it's not, and it's also the first one in the list. If it's not, you're cooked, and you will just, yeah. The velocity momentum split. While implementing the velocity version, the planetary velocities are not simply heliocentric. They must be calculated using planetary inertial velocity minus the total barycentric velocity is adjusted for by the mass fractions. What I is greater than I0 is this. Okay, so we'll be analyze this part. Star's inertial momentum and momentum here will it's literally just mass times velocity, so I can just divide by mass. Okay, so I assume M0 is just the mass of the star. I assume that's okay. Good. Okay, I'm not being stupid. So you can just use this directly. So if I divide by M0 here, so you also have pH dot velocity is index 0. index 0 is p0 divided by m minus this whole thing divided by m0. Wait, momentum is our oh no, this is democratic heliocentric to inertial. It's me being dumb. Yeah, this is center mass position. That is sensical. Now P0 is the total system momentum, and if you divide by that by m, double total momentum equals 0. And if now pragma OMP parallel 4 size Ti equals 0, I is less than particles dot n particles dot stress dot value or particles dot n plus I. Alright. Now total momentum plus equals particles dot mu's index I times particles dot velocities index I, and then pH dot velocities index 0 should equal total, not through ASCII, total momentum divided by particles dot mu's index 0. Oh no, that's maybe, no, this should not be here actually. So I'm just gonna go ahead and grab this and just do void in inertial to WHDS vel, and we do a very similar thing, except for the fact that I forgot the restricts here that are just gonna kind of important. And particle store pH, and okay, that should be done now. That part should be fine now, and okay. And then this part should be easy. Pragma will be parallel 4 size T equals 0, I is stand particles dot stress dot value or particles dot n plus I. And what we do is we just first cache this just in case, like vec3 star pos equals pH. I could probably throw this in here actually. Vec3 star pos equals this. So we have pH dot positions index I equals particles dot positions index I minus star pos. Wonderful. Restrict that too, and what is it? Total momentum plus equals this. That's not a double actually. Yeah, that's it. It's just a vec3, and it doesn't even need zeros. Okay, so I dealt with pause. That's like trivial. That's literally just copying this in. Yes, this is a strategy to use. The assignment returns a reference to the original object. Therefore, I can just copy it into another variable. Okay, next. Now for planetary momenta, which is equal to velocity, pi equals pi minus mi over mp0. So what if I just divide the whole thing by, say I only have velocity, so if I have v total system momentum, okay, so first we're gonna have to store total system momentum in another variable, but it's already stored here, so I guess. And you're just gonna divide by mi basically. Except you don't have total mass, which is another thing I just, I've been typing the same loop so many times. The same mass loop so many times. I probably should have determined that, but alas, no. So just do double total mu equals 0, and now this is going to be no longer a block. Okay. Total mu plus equals particles dot mu index I. Wonderful. Okay, pi is going to continue on. So this is going to be vi minus, now this is going to be trivial now. Pragma OMP parallel 4 size t I equals 1, not 0, 1. I is less than particles dot thrust particles dot n plus I, and we just do a very basic thing. Velocities index I equals particle dot velocities index I minus total momentum divided by total mu. I think this is correct. Let me check this, and that's not correct. I checked it. So WHDS pause. Oh yeah, I kind of articled this value, and it was just like, usually that's true, not this time. Okay. Grace conditions. And why I keep forgetting reductions. This is why I hate this. Reduction plus colon total momentum total mu. Okay. Let's copy this again. Okay, just minus v0. That's a barycentric velocity. Particles of velocity is index 0. Particles of velocity index 0. Okay, so now I guess I can get rid of this work. And this. And make another single statement 4, which are quite possible and are more beautiful things in programming. If done correctly. If done incorrectly, they're a nightmare and I can talk. Okay, Gemini, please. Major mathematical laws. Wait, what? Total mu is not a thing. What kind of... Okay, bro. Oh my god, bro. You are just like... What do you want me to do? Do you want me to do barycentric or inertial Gemini? Which one is it? What Gemini? Nice, okay, I know that part's gonna be incorrect, but still. Pause, val, total mu. What? Okay, is it just trying to... Okay, I think it's just wanting me to add a total mu out of context like this. Adding total mu back in. Now if I just do total mu plus equals particle dot mu index I, we can now get total momentum divided by total mu. Okay. Pasting this in now. Hopefully this is correct. Okay. Sends to zeros, WHD and WHDS. The zero, but the total barycentric velocity. Okay, so it has to be divided by the total mass too. Okay. Total mu, and at this point, vector bary is just. I can just do this now. Okay. Okay, now bary integrated to val. Okay. And now, okay, now we want me to throw the thing and throw the stars velocity in here. Now I don't know what's that happening, but star val equals particle dot velocity index 0. So star val, and I don't need to make a variable. There we go. Paste this again. Hopefully it works and it's not just gonna. Okay, nailed it. Okay, nice. Nice. Okay, now I need a formula for. Now I'm just gonna scroll back up to here, yeah. Okay, P0 is this. So we have M0 times V. Okay, so we have M0 squared. That's confusing. That's interesting, but you only have so let's do this. So, and of course, we have the total momentum of the rest of them. Let me just write this down in code. It'll be more obvious how to get rid of extra stuff later. The moment I actually finish writing it. Void. What is void T? Anyway, void in WHDS to inertial pause. Okay, so stuff we have particles dot position index 0 equals Q0 minus that monstrosity. I guess it's best to store this in a variable and then assign it to particle store later. Vector star pause equals x q0 minus this. I'm just gonna assign. Let's call it star pause correction instead in this. So we have n this stuff. So for size t I equals 1, I less than. And now we need to subtract this. We don't have total mass though. Time to get total mass. You got to compute total mass so many times. This is not fun. At this point I should probably pass total mass into here and so I don't have to do another 10 billion open MP loops to figure out total mass. Only need to do one of them, but anyway, that's besides the point. 0. 4 size 0 is less than. Total mu plus equals particles dot mu's index I reduction plus colon total mu. Pragma OMP parallel 4 reduction plus colon star pause correction. And now the formula here is Q0 minus this. This part is gonna be not a correct. This is not a correction, so ignore that. So we have stars pause correction plus equals mj over m. So we have particles dot mu is index I divided by total mu times pH dot positions index I. And now we have particles dot positions index I, index 0 should equal pH dot positions index 0 minus star pause correction. Okay, xi equals x0 plus qi. Yeah, actually, I should actually just vex3 star pause equals this. And now triangle be parallel 4. Size t I equals 1. I is less than particles dot n plus I and xi, aka particles dot positions index I should equal x0 plus qi. So we have star pause plus pH dot positions index I. Okay, wonderful. This one's easy. Now WHDS to inertial vel, very similar signature. Particles particle store restrict pH. Okay. Now, okay, reading through this. P0 should equal this. Not into analyzing this actually deeply. Okay, M0. That's M0 times V0. That's M0 squared over M. That'll just be M0 over M times V again. The more important concern is there's a big summing here, so yeah, we're gonna have to address that. Vec3 star vel correction. Background people 4 size ti equals 1 I is less than all the way up to particles that has stress. What the just happened there, bro? Test stress. That value or particles dot n plus I. And we say star vel correction. Oh yeah, let's also, I can also concurrently run a total mu counter here, so I'm gonna do that. Star vel correction plus equals pH dot dot mu's index I times pH dot velocity index I. Yeah, and this part will have to be divided by 1 over m. It's 1 over the mass of the star, so go figure. And go from 1 to p. Okay, sure. And this would be total mu plus equals, yeah, the total mu is used here, so we definitely need it. And yeah, that's basically just summing this now. This is a thing that's been routine for now, and I have to set a reduction colon star bell correction and total mu. Okay, and now it should be particles dot velocities index 0 should equal m0 mu's index 0 divided by total mass, which is total mu, and then you multiply this by velocity. Index 0 minus star bell correction divided by particles that mu index 0s plus colon star bell correction. What's the error? Expected expression. It's a reduction. I don't know what's happening. So, what kind of glitch is this? Surely the logic is kind of correct at least, but let's ask Gemini. It is erroring on this line, and all the other vec3 components, vec3 object reductions are not doing that. Yeah, I literally did that. There is a reduction. It says expected expression. Yeah, okay, I literally included. Yeah, the issue, it's still, yeah, but like, it should have made the logical connection that this would have broke if that was true. It should have made that connection. I don't know what kind of non-connection it's making, but like, yeah, okay, let's see. Okay, let's just copy this name in here exactly and paste it right here. Oh my god. Reductions with vec3 in this file are fine. It is just this one that is erroring. Yeah, I swear I did that. I don't know how. But what kind of glitch is this? Yes. Okay. So, what's the error? The expected expression happened with pH and work constant in function signature. Okay. What is this error? Because that's just happening. Because it's not even capturing anything. The error is 277.38. No expected expression. No other detail. Line 22277 is the only pragma in that function. I don't know what's... Okay, yeah, that's a weird thing. 'Cause, I mean, it's been working literally. I put a vector and a double on the exact same line before. Like, I don't know what's... Yeah, oh my god, no. What is this error? I'm just gonna do starvel C, and I can't possibly error if I just had this name here. Or it could just be my editor being stupid. Never mind. Okay, yeah, actually it is my editor being stupid. I just had to edit the name real quick. Okay, yeah. Nope, never mind. That was my editor hallucinating. Yeah, okay, good. Now I can go back up here, and actually I should go back up to the map. Here we go. Good. And now, wonderfully, we just have vi plus this. Raw more raw math. x0 plus qi. mi p0. Undo, now there was an accident. For size t I equals 0, I is less than particles dot particle dot n, actually not test stars plus I, and now this is trivial. Mi, that would be p0 is, yeah, value we already have, so yeah, mi over m particles dot velocities index I should equal, so we have m0, we have mi, so m0 over m times p0 and we this is basically the same piece as the first term of that. And now we add pi. Okay. The velocity is index I. Okay, wonderful. Okay. Code looks to be done. And now if I go down to the bottom, thank you. Inverse transformations. Okay, position inverse. Okay, I might have overcomplicated this part. Well, so I'm just gonna get rid of this shit, I guess. Okay. Eliminate the loops and now just directly read it. This is a relatively trivial check. Position index 0. And I don't need to copy this anymore. I could have just put ph position index 0. No, let's actually do copy this. Okay, velocity inverse. Step A. Mathematically compute the term. Need to calculate total mu as the total mass of the entire system. So the Starvell correction should accumulate that the pH velocity. pH dot velocity index I. Okay, dividing the entire calculation of data star's mass. Okay, this resolves to that, which is pretty clear, to be honest. Yeah, I'm just gonna, let's see. So let's not overcomplicate this stuff. It's literally just gonna be V0 minus that. Starvell correction, MI over total. So total mass you're gonna need to figure out. But total mass here doesn't actually... total mass here does include the star. But like, it isn't any variable that changes in there. It's an external variable, basically, that just happens to be tied. So I think what we can do is just grab your total mu and just total mu plus that, and let's just say total mu plus equals particles dot mu is index 0. So I can just use total mu directly. And now hopefully invalid operands. Okay, how did that guy just that other guy just disappear? Okay, particle dot mu is index 0 divided by total mu times this monstrosity. Mu times this. Okay. Okay, what? Oh, I forgot. I was planning on doing that. Interesting. Yes, okay. Now let's paste this, or let's just paste the entire WHDS section, rather. And hopefully it's correct, though it probably isn't. Your inverse function still contains two mathematical discrepancies. Emits execution bound. Total mu assumes that all planets are accounted for. This is total mu completely mismatching the scope of Starville correction. The mass and momentum reduction must loop over every particle up to the system. Do not use test structure. You need true total mass of the entire system. What? I can't use test stress here, but let's check if the code actually relies on anything funny with test stress. Interesting. Yeah, it literally does have test stress involved. I'm not sure what kind of drugs Gemini is on, but it should be fine. And also, how does adding this afterwards implicitly assume that this entire section is doing the entire system? There's no assumption, that's just adding that afterwards. The mass and momentum reduction must loop over every particle in this system. I don't know. Look at the math inside of your final planetary loop. The problem, this formula mixes in a mass scaling fraction of the barycenter. That's a variant of the WHD inverse mapping. Remember how the velocity, you just add it back. Wow, that's so shocking. But yeah, I guess it's fine. Let me just edit this now. Now we can get VI plus V0. So, vector V0 equals this. And now if I do V0 plus this, boom. That should be done. And now I guess I'm also supposed to just put particle.n. Okay. Pasting this in exclusively. Okay, implementing. Wonderful. And now we're going to write some tests. This time I'm going to show you. It's just going to be a forwards test. As in, can they undo each other perfectly? Or close enough to perfectly, rather. Okay, so nvim unit test / transform unit test / Jacobi transform test.cpp. Yeah, I'm using this one for this job. Inertial to the WHDS, and then you have WHDS to inertial. And we also are gonna do a similar thing for the velocities, and so there are two different transformations here. So we have inertial to WHDS vel p and useless, and we do the backwards one here. So to inertial vel p useless. Oh yeah, and I guess total error can also plus equals I dot vel minus org index I dot row. And now it's 2. Now the error allowed is 2. No, transform, not transform. So now let's run our unit tests and the build script. Everything passed. Wonderful, amazing. This is shocking, though Sam and I probably did do a bunch of debugging, basically. So, okay. Nice. I'm gonna do the commit. I did WHDS. And now I'm gonna end the video.